Welcome, everyone. For today's prep, we're going to look at one or two more examples of these algebraic methods for dealing with that indeterminate form 0 over 0. So, our main strategy is to try and factor and cancel, but sometimes we got to do a little bit more. And so the example we're going to start with today is the square root of x plus 25 minus 5 all over x. And we're doing the limit of this function as x approaches 0. All right, so as usual, when we have a limit where we have a nice function here and x is approaching a number, first thing we should do, plug the number in and see what you get. And in this case, if we plug 0 in, we immediately see that we have division by 0 if we plug in. And then in the numerator, we end up with the square root of 25 minus 5, which is also 0. So this is a 0 over 0 form. So we can't plug in. Plugging in doesn't do anything for us. So normally our first step, direct evaluation, see what you get. But in this case, 0 over 0 doesn't really tell us too much. It tells us just we got to do more work. So let's write out this limit. We're doing the limit here. X approaching 0, square root x plus 25 minus 5 all over x. And our strategy for this is we're going to try to rationalize the numerator here in this case. And the special little algebraic technique is we're going to multiply by a fancy 1. So we're going to multiply by the conjugate of the numerator here. So what does that look like? Well, it's basically the same thing. So square root x plus 25. And then the only difference is we switch this sign to the opposite. So we go from minus to plus. And then we can't just multiply the numerator by something because that gives us a whole different function. So instead, we have to also divide by it. Because really what we're doing then is just multiplying by a fancy 1. So this is the special part right here this is the trick. So we'll call this the conjugate method. What we're doing is trying to rationalize this numerator. All right, so why is this helpful? Well, let's see what we get when we take the numerator here and the numerator here and we multiply those together. And, if you want, let's actually break this, we'll go down a little bit just to see what we get here. So if you're ever not sure of multiplying something out, maybe go off to the side and work on what you get when you multiply terms out. So let's write it. And we're going to use our FOIL method for multiplying these out. So when we do this, we can, start with the first term. And then we're just going to distribute it to the square root. And then we'll also distribute it to that plus 5. So when we do that, we get, square root x plus 25 times square root x plus 25 is just going to give us x plus 25. The square root kind of cancels itself out there. We're actually squaring it, so it gets canceled. And then when we multiply with that 5, we're going to get plus 5 times square root x plus 25. Okay. And then we go on to the second term here, the minus 5. And we distribute that to both terms in the second set of parentheses there. And when we take the minus 5 and multiply with that square root, you can kind of see maybe where the magic's going to happen now. We're going to end up with minus 5 times x plus 20, square root x plus 25. And then the minus 5 with the 5 gives us just a minus 25 there at the end. And we're adding this thing, and then we're subtracting it right out. So those terms just cancel. So when we multiply this, we end up with just x plus 25 minus 25. So we have the x plus 25 here, the minus 25 there, and then it even simplifies down further. So we have a plus 25 and then a minus 25. Those are gone. So we can actually get that simplified down further. So let's throw that back into our limit calculation. So all we were doing here, we were just kind of working out the multiplication. So there were things that canceled, but it was just addition and subtraction, so that's okay. So what we see is by multiplying these two numerators together, that simplifies to just, excuse me, x. All right, so that's the numerator. We got that all nice and simplified down. We went through the multiplication. Now, if you wanted to, you could do that right in the main line of your work. But if you're not sure, it can be helpful just to kind of do that off to the side like we did and see what you get once you kind of work it out and simplify things down. All right, so we've multiplied out the numerator. Well, the way we multiply fractions is we just take the two numerators, multiply them together, and then we take the two denominators and multiply them together. So our denominator here is just going to be x times, and then I'll put in parentheses, square root x plus 25 plus 5. All right, so we're doing a limit calculation, so we need to make sure we got to throw that limit sign in front. So limit as x goes to 0. All right, so now let's look at what we have. And what we see is that we have x on the top, x on the bottom, and, I didn't really distribute the multiplication in that denominator when we did this. So most of the action is happening in the numerator there. So I just kind of left that denominator just as the two terms being multiplied together. Just don't forget about the parentheses. And the reason why I didn't is because this x is going to cancel out nicely with that x right there. So that's going to be our next step. We're going to cancel that out. So we're going to end up with 1 over square root x plus 25 plus 5. So those x's cancel. So that's usually all these algebraic techniques that we see. Eventually they lead us to the point where hopefully we get that term in the denominator that was giving us 0. We get that canceled out of there. And that's what we've done. So now, as soon as we cancel things, we want to try our direct evaluation technique again. Because if we get a number that makes sense, well then we have our answer. So let's see what we get. We're going to try direct evaluation. As soon as we cancel things out, try direct evaluation. All right, so what are we going to get here? Well, x is approaching 0, so we're just going to throw a 0 in. And when we do that, we get 1 over square root 0 plus 25 plus 5, which ends up being 1 over, and the square root of 25 is just 5, so we get 1 over 10. Perfectly good number. That's our answer. All right, so this is just another little technique that we have at our disposal that we can use to help us deal with these 0 over 0 forms. So it's, what we're doing is we're rationalizing the numerator, and the way we do that is by multiplying by this fancy one term. So we're multiplying by the conjugate here. And then, we get to the canceling step. So we get that term canceled out, and then we can do our direct evaluation. So just another little technique here. One little note just about limit sign usage. Just want to be careful that you're using limit signs throughout. So we got a limit sign to start us off, Then in the next step, we had a limit sign because we haven't done the direct evaluation yet. Then in the next step, we have a limit sign. But then as soon as I do the direct evaluation, as soon as I plug in the number that x is approaching, no more limit sign. So it would be incorrect to write the limit sign here because the limit sign is telling us we're kind of traveling. X is approaching 0. We're kind of on the move. Once we do the direct evaluation, that's us reaching our destination. All right. So what we're going to see is in class on Friday, next time, we'll see another little algebra technique. And that is, if we have fractions, we can work on getting a common denominator. All right, so just a nice little example here to kind of start us off. So we'll see you in class. Bye-bye.